In this problem, we're asked to simplify this expression. This involves negative exponents and a fraction, and the idea is to try and write this as a simple fraction. Exponents are allowed, but negative exponents are not. And so the key to understanding this problem is to understand what a negative exponent actually means and how we can manipulate it. And it's also important to understand that this exponent here, for example, this -2, is on this x, and it is not on the 3. The exponent on the 3 is a 1. When there's no exponent, the implied exponent is 1. So when you rewrite this x to the -2, it will affect what this expression involving the x looks like, but it should not affect the 3 directly. Down here, when we have these parentheses with the exponent outside, this exponent is on every term in the product within those parentheses. So there is a -3 exponent on the 2. There's also a -3 exponent on the x to the -5 and a -3 exponent on the y after we distribute these through. So again, understanding how we can manipulate these is kind of the key piece of this. We will also eventually combine like terms, and we'll need to determine how many are left over when we do that. But the key thing here is the notion that x to the -a is the same as 1 over x to the a, where a is any real number. And again, x can be any variable, so this formula works when we're dealing with the x or with the y. And x, y, if we have a product to the a, is the same as x to the a, y to the a. That'll allow us to distribute the -3. And then finally, x to the a to the b, where a and b are any numbers, is going to be x to the a times b, the product of those two. The order of operations here, since we're dealing with multiplication and division, is pretty much up to you. You can attack this in a number of different orders. So the method that I will lay out here is not the only one, but all of the steps that I will perform will be necessary, just the order may not be the one that you would have seen. I think I'm going to deal with this -3 exponent first, distributing it across the product that we have in here. So in the numerator, I will leave the 3x to the -2 alone and distribute the -3 through. So I have a 2 to the -3. I have an x to the -5 to the -3. And you might be able to combine those in your head immediately, but I'm going to write out each step here. And a y to the -3. All right. And next, I will take care of these parentheses. I will distribute the product here, the exponent -3 onto the x to the -5. That'll leave the numerator alone. I'm going to leave this 2 to the -3 alone for a moment. And then this will be x to the -5 times -3 means positive 15 on the exponent. And we'll leave this other one alone. And now I will deal with the negative exponents that remain. If this x to the -2 can be viewed as 1 over x to the 2, then I can move this x to the 2 from the numerator to the denominator. And that's what I would do next. That 3 is not does not have a negative exponent on it, so it does not move in this same way. But again, this x to the -2 can be rewritten as a 1 over x squared. I could use a little fraction up here, 1 over x squared, but eventually I would be needing to move the x squared down here anyway. So I'm going to rewrite that this way. So this 3 over x squared is the way to write 3x to the -2 using no negative exponents. Similarly, the 2 to the -3 here is division by 1/8. That's a division on this bar by a 1/8. And division by 1/8 is the same as multiplication by 8. So this 2 to the -3 is being moved up to the numerator.